Hello there. In this video, we're going to talk about a function. More specifically, what is a function? So in the previous videos, we talked about domain and range. If you did not watch those, I highly recommend stopping and going to watch those first. To understand what a function is, we start with what a relation is. A relation in a math context is when two numbers have some sort of computational relationship with each other. It could just be random pairings of numbers. It could be I'm multiplying everything by 2. That's what a relation is. We often see these plotted as points on a graph. They could be listed as coordinate pairs, or we could be doing computations with equations. Now, what a function is a relation in which each input maps to exactly one output. So, in other words, a relation in which each x value maps to exactly one y value. So let's go ahead and look at some examples of functions, and then let's look at some non-examples. Okay? So an example of a function, this would be a list of ordered pairs. We'd have 4, 2. We'd have 3, -3. And again, these numbers were just picked out randomly. It doesn't have to be this. This is just one example. 2, 2. So each input maps to exactly one output. That means when I'm listing out these numbers, I'm looking at the x values. Do any of them repeat? And not only repeat, do they repeat as x values? And in this case, no, they don't. So let's look at what a non-example would look like if the x value were to repeat. So I got 4, -3, and I've got 4, -2. I've got 6, 5, and 7, 5. So I look at the x values, and I think, okay, does that 4 repeat anywhere at an x value? And it does. It repeats right here. So the fact that this 4 repeats in 2 different positions mean this is not a function. Now, in both instances, right here and right here, I've got a y value repeating. Is that okay for a function? And the answer is yes. Y values can repeat. X values cannot repeat. I've even got a y value repeating in my non-example. But that's not what's preventing it from being not a function. The fact that the 4s repeat prevent it from being a function. Let's look at another way of representing functions, and that's with mapping diagrams. So generally, they're labeled with 2 ovals. This is the domain, and this is the range. And this is best, vocabulary-wise, what represents what a function is when we say maps to. So I took my coordinate pairs 4, 3, 6, and 2, and I got 2, -3, and 5. And notice the 2 repeats, so I won't list it twice. 4 goes to 2, 3 goes to -3, 6 goes to 5, and 2 goes to 2. So notice, again, each input, so each of the values here gets mapped to exactly one output. That would mean if I'm mapping into it, that I've got only one arrow coming off of each of these. And look at that. Each number has only one arrow coming off of it. So what would that look like in this context? There's my domain. There's my range. I know 4 already repeats. So the fact that should stop me right there. The fact that I would have to list 4 twice should stop me in the domain. But we'll continue. -3, -2, and 5. 4 gets mapped to -3. 4 also gets mapped to -2. 6 gets mapped to 5, and so does 7. And so each input getting mapped to exactly one output. Well, here's this 4 right here with 2 different arrows coming off of it. That means it gets mapped to 2 different values. Again, we've got the 2 here having 2 arrows coming towards it. That doesn't affect our answer. The 5 here as well. Does each input have 1 arrow coming off of it? Okay, now let's look at graphs. Okay, so I'm going to sketch a graph, and we're going to use something called the vertical line test. So I'm going to just graph a function that looks like this. Okay, that's my graph. Now, the vertical line test applies because we're talking about taking x values, say this x value right here, and we're mapping it to the graph. And do we only intersect this graph once? This is where the vertical line test gets its name. We are effectively drawing a vertical line, and we are seeing that at any x point, does it look like we are intersecting the graph at more than one point? And you can, I always say, imagine you're using your pen, and your pen infinitely extends vertically, and you hold it up to the graph. Can you move it anywhere and be assured that it will never intersect the graph at more than one point? That's what makes this a function. So for this one, I'll go ahead and give you an example of a graph. It's not a function, and it's quite a famous shape. It is a circle. And this is actually a good example because, say I want to draw my vertical line right there. We can see it will intersect the circle there and there. So it'll intersect at more than one point, making this not a function. So we've got ordered pairs, we've looked at mapping diagrams, and we've looked at graphs, and they each have their own kind of succinct rule that we can follow to determine if each input repeats. With ordered pairs, it's just look at the x values. Is any x value listed more than once specifically as an x value? In mapping diagrams, does each of our domain values have more than one arrow coming off? And then with graphs, it's the vertical line test. So this would naturally usually lead me into equations. What might an equation look like if it wasn't a function? What might an equation look like if it was a function? And I don't think I'm going to address that in this video because I've got a whole series of videos discussing types of functions that are, types of graphs, I should say, types of relationships that are functions and types that aren't. And there's no good way for me to summarize when an equation is and when an equation isn't. You have to take it on a case-by-case basis. So we'll leave that for another time. If you liked this video, please like and subscribe and leave a comment down below, and I'll see you for future videos. Thanks for watching.